Hey, good morning, guys. First off, just want to say that sorry to get the news, yesterday about the remainder of school and what it means, for you seniors not finishing out your year as you had imagined. I feel for you guys. I know it's a tough time for you. So I appreciate your effort, your patience, everything that you've kind of been doing here in class. We've definitely had some slip ups along the way here, and maybe some of us we got to play a little catch up, but I'm confident that we can do that and finish out the year, strong and definitely handling, all the different material that we have to make sure that we finish in the next month or so. So, thinking about you guys, hoping you're doing well, and hoping that who knows that see each other again sometime soon. All right, so we're going to go over the review from yesterday. Quizzes tomorrow. I hope that you watch this video. Going to strongly encourage it in classroom. You're going to have problems just like these. You're definitely going to have one that'll be set up just like number one, where you're given stats. You're not given the data. So it was a little less work. And number two, I'll only give you one of these because this is definitely a little more time consuming. All right. In addition to these two problems, you might also get some problems where I say, look, just give me the hypothesis, just state the HO and the HA. Or I might give you a problem where I ask for you to read through the scenario and tell me, which one of the conditions might not be met. So make sure that you are reading the directions, doing what's asked of you in the problem. Okay. So like I said, there's going to be one where you kind of completely do a test like this one where you will do a test like number two. But there'll be some others where it'll be a lot less short of a response. Just give me the hypothesis or give me, the normal large sample is flawed for whatever reason. It's going to be something like that. All right. But for now, let's just kind of go over number one. All right. So this was the one where, you were given, let's see if I can open this up. Okay. So in this particular problem, we're told that safe drinking water should contain no more than 1.3 milligrams per liter of copper. We're testing water from a new source. We take 30 water samples. The mean copper content in this particular set of 30 samples was 1.36, okay, and a standard deviation of 0.18. So we're given stats. We're not given the exact data. We're given the sample mean and the sample standard deviation. So we can just go to the calculator and address this one a little more simply. All right, so you'll see I have my calculator up. And from here, I could just go to menu, 672. All right. Now, prior to me actually doing this, like I said, we have stats, but prior to me running this t-test, let's just focus on, let's go back to, we would have to, I guess, assume here, because I don't think we were told random. So we'll assume that it was a random sample of 30 that was taken. We would assume that 30 is less than 10% of all the water sources. This third and final condition is the one that I've been saying be the most attentive to. The problem didn't tell us that it was a normal distribution. However, the sample size is large enough, right? So that's why it's like, as you're thinking about this, you're kind of checking this off. Well, it's not normal, but as long as it's 30 or bigger, it's considered large enough. Once the conditions all check off, now I can go to the calculator and I could type in my HO, which was 1.3, our X bar, which was 1.36, our standard deviation, which was 0.18, and we sampled 30 water sources. We hypothesize that it's going to be greater than, because we're checking to see if it's unsafe, meaning anything above 1.3. And there you'll see our p-value. Okay, so there's the p-value. I wrote that down, and now we just have to write our conclusion. So again, the models of these answers have been given to you a lot. So we should definitely have an idea of how to form our answers. And I expect it to be formed just like this for full credit. So the p-value is less than our significance level, which means we reject the HO which means we have evidence. All right, we have evidence in this case that the water from this source contains unsafe levels of copper. All right, in other words, we reject this HO here because our evidence is strong enough for us to believe our suspicion that maybe this water is unsafe. All right, so that's the first one. And number two, you're presented the information a little differently. All right, you're not given the stats that I mentioned. Rather, you are given data. Okay, this one, like I said, is a little more time consuming. So there will certainly just be one of these that I will ask you to do tomorrow. In this one, you'll see that I've already entered the data just to save us some time, but you'll go to a list and spreadsheet. You'll have to enter the data here. And in this case, this is miles per hour that 10 different cars had traveled through this construction zone. So I labeled it miles per hour, which you'll have to do when you graph. And just take your time when you enter that data. I'm going to hit Control-I real quick and add the data and statistics. Click to add a variable. And as we can see from the dot plot, but if we're more comfortable, we'll check the box plot. There's no skewness. There's no outliers here. Okay, so it's safe to continue, meaning, this condition's satisfied. All right. Beyond that, once we do that, we'll have to find the p-value, which, again, you'll see it on my screen, but I'll show you how I did it. I hit Menu, Statistics, Stat Tests, T-Test. They weren't the same numbers, but they were the same prompts as in the last question. They're just numbered differently. But it's Statistics, Stat Tests, and then T-Test. This time, we do have data. All right. Our HO is 25, right? The speed limit is 25 miles per hour. Our data is in column A. You shouldn't have to change that. It should be in column A. We are hypothesizing here. It says, is there convincing evidence the average speed of drivers is greater than the speed limit? So are these drivers going faster than 25 miles per hour? So is it a greater than? And our results can go in B. All right, so there's our test statistic. More importantly, there's our p-value. Again, it's a pretty small p-value, which means that we're going to end up rejecting the HO, and we're doing so because, our data here says that we have strong evidence. It says we have convincing enough evidence that drivers in this particular construction zone, are speeding. They're going more than 25 miles per hour. I just noticed here as I was, as I'm looking back, this HA, little typo here, this is supposed to be greater than 25, not 5. All right, so that's supposed to be 25. The conditions are all spelled out for you. But again, be most attentive to this one. Understand how this works. Did the problem say normal? No. Is it large enough? No, because there's only 10, right? Not 30. So we had a graph, and the graph did not show strong skewness, didn't show outliers. So I wrote, it's safe to continue. It's safe to say that this condition has been met in one way. All right. So again, guys, this video will be uploaded. You'll see it. Watch it if you care to. I'm going to encourage you to. But again, this is what to expect for tomorrow, in addition to some shorter problems that might ask hypotheses or might ask the conditions. All right. Guys, have a good rest of your day. Let me know if you have any questions for tomorrow. If anyone has any issues with the calculator, one of your classmates, Alexis, emailed me or sent me a message that she had found a pretty good functioning calculator that handles this stuff. So if you're someone that needs that information, let me know. All right. Have a good one, guys. Thanks.